Cool. Welcome everybody to the CEID Virtual Electronics Workshop. You have the floating menu controls, great. Yeah, so normal. I mean, some more people might roll through, but otherwise, if it's really just like only a handful, we can totally do this a little bit more conversationally and just explore different things that you might be interested in. Matt, do you have prior experience with any prior experience with electronics?
Yeah, so I took EE 200 last semester. So I have that, I guess, but not much more, and like just basic like electronics in my car, but not much with like prototyping.
Gotcha. Have you used Arduino before?
I haven't, no.
Okay, so this will definitely be at least that will be new. I won't, I'll fly through the details of like what is electricity, but we'll cover a few things that hopefully will be a little interesting. And for the sake of the recording, I'll just go through this presentation and then we can get started. Have you ever used the Tinkercad prototyping or digital prototyping software?
Nope.
Great. So that'll be really exciting. And if you haven't already, you can go ahead and make an account, but we can cover that as well. Looks like you got one more person coming in and then we'll get started. Hi, Alvin.
Hi.
Welcome. It looks like we got not as many people showing up right now, or they're going to roll through a little late, which is totally fine. We'll go through the presentation, but since it's a small group, we'll be able to explore anything that you're interested in. Do you have prior experience with electronics?
No, not at all. First
Okay,
time.
great. Awesome. So this will be hopefully an introduction to something really interesting. We'll go ahead and get started. So welcome to electronics, specifically with the Tinkercad online electronic prototyping platform. We're going to go through some slides and then we'll jump into Tinkercad so that we can start playing around and simulating some electronics. And I've got some, not demos, but some live like actual physical circuits that I can show you so that gives you a better idea about what it actually is. So going through, we can talk about, well, why learn electronics in the first place? The short answer is because electronics are literally everywhere. They encompass pretty much every aspect of our lives, from not just the screens and the technologies that make our phone work, but there's motion sensors, there's temperature sensors, communication devices in there. Computers nowadays are having bigger and more robust processing hardware. Even things like doorbells are becoming electronic and becoming really smart, all the way to like rockets that land themselves to cars that drive themselves. And the important thing to really know is that, or to feel, is that it's not like the Tesla just like appeared out of nowhere and it was like, look, it's a self-driving car, like surprise. It was an improvement on multiple things, and the previous cars, and the cars are improving on previous technologies, and even something like a self-driving car has to start off as something like this, which is just like this really something that looks like a kid could make in the garage. But it boils down to just like a couple of electronic components that are put together with some code that let you create a little device that can interact with the world in whatever way you see fit. Some projects that I've worked on myself within the CEID, and this project was a former CEID like workshop thing. I myself have done multiple electronics projects when I was an undergrad. So this is like a little robot spider that I built that was run off in Arduino and some servo motors. It was horrible to build. I designed it in CAD, and then you can even design your electronics along with the actual CAD that you make. I made this little ball that's a musical instrument, and it's also good to realize that electronics don't always look very pretty when you put them together, but the end result usually looks a lot better. And as you go through, we can start to think about electronics in sort of two camps. There's analog electronics and digital electronics. The analog is what you might see as these sort of complex circuit diagrams. Most of the fundamental components that you work with in a circuit or in electronics are inherently analog, right? So your resistors, your capacitors, diodes, transistors, these are all analog components because you just put something in and they respond, but you can't like code a resistor. You can't like upload information. Now, as you get to like transistors, technically you sort of can, and that's how like computers are made. But that's further down the line. Usually these components are not that expensive. But making a circuit that's entirely analog usually is a little bit more difficult. And these are faster, but they're also more susceptible to noise, so there's trade-offs. With digital electronics, which is what we'll be working with, these are typically much easier to access as a beginner to the world of electronics, especially writing code to control your electronics. And this is when you start to get into things that have like memory and have addressable information. It can span from a processor like a Mac or a computer, all the way down to a small microcontroller like an Arduino, which essentially is a little computer, but you can just code directly to it. These tend to be a little bit more expensive than their analog equivalents, but they're a lot more accessible to use, and there's a lot more information just like for the layman out there. And of course, the types of signals that they send, you can think of the analog as this sort of continuous signal back and forth, whereas digital, you can usually work with signals, whether it's like something is high or something is low. That's the sort of curve that you can send back and forth. And of course, most technologies that you use combine some version of analog and digital components. You're almost never going to use anything that just uses analog components unless you're like a total hardo making like a speaker, and even then you're probably using some digital components to do sound cleaning or things like that. But there's all these terms that may or may not matter to you, but they exist in the world of electronics and doing different various things. Now, Arduino itself, and this is a word that you're definitely going to hear a lot if you start to explore what sort of things you can customize or create with electronics. Arduino is a platform that was founded in Italy that is an open source sort of community that allows people to sort of democratize electronics. Before Arduino, really only like electronic engineers and people who really dedicated themselves to that field were able to create and modify electronic components, lights, motors, things like that. When Arduino came around, they really popularized this idea of making addressable and manipulable electronics accessible through various things: a software platform and a hardware platform. So this is like what the original, or not the original, but like the basic Arduino looks like. For context, I have one in here. This is like the size. So it fits in the palm of my hand. It looks just like that. Got like a bunch of pins that you can connect to, a USB port, a power port, and then the software platform kind of looks like that. And the software is free, and the community to interact with Arduino is free, and that's sort of part of the reason that it's really taken off and been a huge part of why electronics and the study of manipulating and customizing electronics has grown so much. And then the hardware itself is actually very inexpensive, right? You can get an Arduino now for like $20, if that, and there's lots of copycats on Amazon that you can get for $10 and they work just as fine. The perks of Arduino is that it makes it really easy to write a little bit of code, even if you're not a programmer, and connect a few wires here and there, even if you're not an electrical engineer. And all of a sudden you can interact with buttons and lights, you can move motors around, you can interact with a GPS signal, you can play sound, you can take a photo, you can connect to the internet or connect to internet-enabled devices. Lots and lots of fun stuff. Now, the Arduino is just one of these devices, but Arduino really has a suite of different, things that you can use to enable your project, right? So maybe you needed something that's a little, smaller or bigger, right? So one on the left is a little itty bitty Arduino called the Arduino Nano. For context, here is an Arduino. This is the Arduino Nano. And you can imagine if you're wearing using things like, creating a wearable device. Maybe you want to make smart glasses or a bike helmet. You don't really want to strap this big hunkin', thing to your head. Maybe you just want to use something small. Or maybe you're working with some heavy duty motors or a lot of different motors or lights or something. Maybe you need a Mega, which is a little bit bigger than a regular Arduino, and it has like 50 pins rather than just 20. Maybe you need something that can connect to the internet, right? So in that case, you'll want something like this, which is like the image on the left. This is called a feather board, and it works just like an Arduino, but it's made by a different company. But Arduino has become so popularized that basically this company made it so that you can connect to this by using the same code that you would use to connect to an Arduino. And then maybe something completely different is maybe you want to write Python code and you want to connect to a screen and connect to the internet and do all this stuff. That's all built into something like a Raspberry Pi, which is over here on the right. And again, that's made by a completely different company altogether, but it's sort of still along the same lines of electronics and democratized electronics, where you can use it and very quickly build up a project or idea, whether it's for a personal project or for a startup, whatever that might be. Now, what we're doing today is exploring ways to prototype these digital electronics in a digital platform, given that normally in electronics workshop in the CEID, we would like give you an Arduino, we would give you some wires and some motors, and you could put them together, and by the end you could have this little robot that moves around. Sadly, we can't quite do that right now. What we can do is use the power of the internet and prototype these electronics using something called Autodesk Tinkercad. Now, Tinkercad was initially created as a CAD program to teach CAD to kids, but it actually has a pretty great our electronic prototyping, I think this is really sort of underrated. Now it doesn't have like everything that we would be able to prototype in person, but it has quite a lot. And hopefully you'll see that as we go on through. If you don't have a Tinkercad account, it's completely free and it takes like 2 seconds to sign up. So if you haven't done so already, I'd recommend you go to tinkercad.com, click join now, create a personal account. Don't do like the school accounts. And then once you see a dashboard, which is probably empty, you want to go to circuits rather than 3D designs. And then from there, you should see the workspace. And then from there, we'll get started. Now, Tinkercad isn't the only platform for prototyping electronics. If you are looking to do something more advanced, right? Say you're already somebody who knows how to create a circuit, and this is going to be like total like review, or it's like elementary for you. What you're looking for is a way to maybe take your electronics to the next level. So perhaps you've this is a circuit that I'm working on. You've created your circuit and it's got a battery charger and it's got the LED counter and a sensor and a radio and an LED and a button or a speaker right there. And you say, I don't want to ship this to a potential customer. I want to ship something else a little cleaner like this. You can start to move towards software that allow you to do that. Sort of things like Upverter, which allowed you to do like actual professional or more professional circuit design. And then this is what you would give to a manufacturer, either in the US or overseas somewhere, that would then produce these by the hundreds or thousands or millions or whatever it is you're trying to do. So that's my general electronics overview. Welcome, Jack. As you can see, we have sort of a small workshop today, but that's totally fine because that means we can be more conversational and ask more questions and cover what you want to cover. Does anyone have any questions or thoughts or things they want to talk about? That's totally fine. At any time, feel free to just pop things in the chat. Every now and then I'll post some code if we're ever doing something with code. Otherwise, let's start going through the circuit platform and making some circuits. Now, you won't see all of these. This is just like things that I've played around with over the last couple of months. I realized I made a lot of circuits. But if you're in your dashboard, you can come over here and you don't want to click 3D designs, you want to click circuits, and you'll create a new circuit. And then we'll open up the dashboard and then I'll pause here. And if people are following along, can you just give me a thumbs up that you were able to get here? Awesome. Jack, do you have previous experience with electronics? I'm just trying to get everybody's experience levels. That's okay. All right, let's keep on going. So this is your workspace. Now, normally you'd be working on an electronic bench in the CEID. What we have now is this sort of gray area where to the right you see lots of these like different components down here. Here it says discover pre-made circuits to build from starters. If you click this components list, you can go to either the basic components, which is a sort of curated list of very easy to use components, or if you click all, you'll see a list of like every single component that it allows you to interact with. Let's see, sorry. Right here. So all the way from resistors, capacitors, different types of capacitors, buttons, potentiometers, motors, distance sensors. If we keep going, we got different types of LEDs. What we'll be working with today is discovering ways, one, to use this prototyping platform, and two, explore ways to combine different types of circuits to make different colored LEDs. It's all the rage these days to have like your room covered in these like strips of LED lights. At least that's what I see on TikTok. So we'll show you how to make that, or maybe you can make like a lightsaber that lights up, or add some cool light colors to whatever project you're working on, whether it's like a tech project or an art project. Be lots of fun. So we're going to use these later on today. But you can sort of explore to see what things you can prototype in here. So if maybe you're doing a project with motors, you can use a DC motor, a servo motor, a motor with encoders, a remote. That's pretty cool. We should use that next time. Displays, different types of batteries. You can even use a potato battery. That's kind of fun. Different types of breadboards. And then, of course, your Arduino. So we're going to use quite a few of these today. But for now, what we're going to do is I'm going to switch to the basic components. And you can always search anything that you want. But I'm going to go basic, and I'm going to click the LED and then drag it into the workspace. You can sort of see how I'm moving that in and around. If you click again, it'll set it down, and then this blue menu comes up that says, all right, you just dropped down an LED. Do you want to name it? And I'll say, yeah, sure. This is my first LED, whatever. Then you can actually change the color of the LED now. This is not like changing the color of the light. This is just saying what kind of LED do you want. So if you have a single colored LED, they come in different sort of lenses that diffuse them in different colors. And in our case, we could do one that's green or yellow. I'm gonna stick to the classic red LED for now. And then you click away, it'll get rid of the selection. If you click it, you can change that color again. You can also click and drag it somewhere. If you click it and then hit R on your keyboard, you can start to rotate it. So maybe you'll want to align things in different ways, or you can delete it, or you can undo lots of stuff here. That's the workspace. What we're going to do now is see if we can light up this LED. This is like the hello world of using electronics. In our case, we're going to go through and find a battery. So I see right here we have a 9-volt battery. That's very common. We'll drag that in. I'm going to rotate it so that we can look at it, side by side. And then you can see that we have a cathode and an anode. If you hover over each of the pins, it will tell you what it is that that pin is doing with that, or that sort of like line of the electronic component, and that'll give you insight into as to what to connect it to. For LEDs, they're a type of diode, and a diode always has an anode and a cathode, sort of. And that basically just specifies which end is going to connect to power or connect to a resistor or something else. Funny enough, I actually forget. For the cathode, you want more. So it's okay. We'll know exactly which one it is. So in our case, let's connect the negative line of the battery to the anode, and then the positive line to the cathode. So if you just click where the red box shows up, you'll see that this wire starts to come out, and you can extend it anywhere you want. We can actually just go straight up and connect it to the anode. And once you click both red boxes, you should see that the wire sort of deselects, and you can change a different color. So maybe you want this to be a black wire because we just connected it to the negative of the battery. And I guess you can even do different types of wires. We'll stick to normal. And now maybe you want to hover over the cathode and connect that to the red line, the positive of the battery. If you ever wanted to delete a wire, you can just click the wire and delete it with backspace or delete. If you want it to bend, you can drag out here, maybe click again, and that'll create a little corner bend in your wire, which you wouldn't do in your life, but we'll do it right now. Can everyone get there? Thumbs up. Great. So from here, hopefully I connected this correctly. Your circuit's connected, but even though, in real life, if you connected the battery to a light like this, things would start happening. Luckily, since it's a simulation, we can choose when we want the battery to suddenly have, electric juice. In this case, this button right up here in the top right corner that says start simulation is what you would use. If you just click that, nothing happens. It's because I chose the wrong connections. I'm going to delete those wires. I knew I was going to pick the wrong one. You want to connect the negative to the cathode. Cool. And then the positive goes to the anode, the bent leg of the LED. We'll switch this to red. Great. Switch that. My bad. Now, if you start simulation, you should see something happens, right? The LED is lighting up. Sort of. We'll tell you exactly what it's doing. But do people see that it created a little explosion? Great. That's actually bad. If you did this in real life, you would have broken this LED. This is signifying that it's exploded. If you hover over it, it actually says the current through the LED is 915 milliamps. The absolute maximum is 20. So you just absolutely shattered this LED. That's bad. What's happening? Basically, the battery is giving out 9 volts, and the LED is saying, "Oh, I can only take a certain amount of current." Without getting into too much detail, this idea of like current, resistance, and voltage they're all related, right? And the amount of current that you have through a component is sort of directly related to the resistance that it is giving to the voltage that's applied to it. That makes any sense. Julian is probably like, this is all wrong, but that's the way I like to think about it. So in our case, this LED is getting too much current, so we want to resist the amount of current that's going into it. What might you use to do that? You could use a resistor. Again, this is like super basic circuit. I promise. If I'm going too fast, somebody shout it out, or if I'm too slow, shout it out, and we'll be happy to go a little faster. Okay. I will drag in this resistor, and sorry, if you search resistor in the components list, you can find resistor there. This is just a resistor. This is just like an analog component that basically is like a kink in a hose that makes it harder for voltage to get through, so it creates more resistance, or rather current to get through. If you click the resistor, you can name it different colors. You can also change the amount of resistance. So in our case, this is saying a kilo ohm. That's the unit of measurement. You can change this to maybe 300 regular, just good old ohms there. And you can see that it changes the color of the bands on the LED. So I'm going to go ahead and delete this black wire here. And I'm going to connect a wire from the negative of the battery to the terminal 1 of the LED. We'll call that the black wire. And then from the other end of the resistor, and it doesn't matter if you do terminal 1 or terminal 2, we're going to connect that directly to the cathode of the battery. And I'm going to change this not to black, but rather maybe to like gray, to signify that we're going from ground to the resistor to this. And if you're wondering why the resistor is on the ground line versus on the power line, you can actually do either or. I like to do it on the ground. It's just like reducing the amount of voltage and current that's going through the LED regardless. So I'm going to hit start simulation now. And you can see that now the LED is lighting up in the way that it's supposed to, not exploding. Although there is a little question mark there in saying, hey, the recommended maximum is 20 milliamps, and you're actually putting in 22. That's a very small, difference. It's not going to blow it up the LED. But if we did want to stay within an acceptable range, we could increase this to say, 330. And now let's see how much current did we put in. We're pretty close. If you wanted to be extra safe, you can switch this to kilo ohms. And you can see that it got way dimmer. So you can start to imagine that the relationship between the amount of current that's flowing in and the resistance is inverse. So as you increase the resistance, the amount of current drops. So the higher resistance we apply to this resistor, the dimmer this battery is going to be, because we're giving it less, sort of like a smaller signal. Does that make sense? Fun. So you can start to play around with doing 300, 3,000, it's a little different, 30,000, even different. And as you go even, to 1 million ohms, it's going to be basically off. What we love are a nice 330 ohm resistor. Fun. To edit this circuit again, we can hit stop simulation, and then we can play around with this. All right, that's your very, very basic circuit. So now you're saying, okay, I don't want just like one single red light bulb. For that, I can go to Home Depot and buy a regular light bulb in my room. What if I want this light bulb to change colors and do fun things? Well, we can go to all components and find a different type of resistor. So I'm going to delete this here. Delete. Cool. And we're going to search LED and see what comes up. And you can see that this sort of white LED comes up here called LED RGB. We're going to drag that in. And this is exactly what it sounds like. It's an LED that can put out red, green, or blue light, or any mixture of those lights. If anyone is an artist, you know that you can mix colors in different ways. And if you're doing prints, if you mix all the colors, it becomes black. But if you're working with light, if you mix all the colors, it becomes white. So if you mix, red and blue, you can get magenta. If you mix blue and green, you'll get some sort of like teal or turquoise thing. Green and red with light makes yellow. And if you combine all three, it'll make white light. In our case, we have, if you hover over here, you have a red, a cathode, a blue, and a green pin. So once again, let's go ahead and connect this resistor just straight up. You can see that it sort of snap locks to it, to the cathode of the RGB LED. And then we can actually start connecting wires to this light. So let's do, for now, a red wire only to the red. And for the sake of demonstration, you see, okay, we're blowing it up. Let me increase resistance to 600. Start simulation. Cool. Nice bright red light. We'll stop that. I'm going to move this wire over to the blue line. See what happens now. It lights up in blue. And we can move it over to the green line. Get out of here. Move this wire over to the green line. And now it should light up in green. Awesome. Now, if we connected maybe the blue and the green line to the power, and I'll change this to blue so you can see that it's actually blue. And we hit start simulation. You can see that it is working. We're actually mixing the colors around. Similarly, let's move the green wire over to the red, switch this to red, hit start. Now it's magenta. And if you do all three connected, you should see just like it's basically white light. We'll go ahead and delete that. But now you might be saying, okay, you know, if I have to put in an LED and connect, you know, a wire and then move the wires every time I want to delete, come on, get rid of it. And then delete, you know, delete the wires every time you want to change lights. That's a little tedious, right? And I would agree. So maybe we can use more electrical components to adjust the type of light that comes through. And the way we're going to do that is with a bunch of buttons. So if you go scroll down from general and you see input, you should see something called push button. If you don't see it, you can just search push button and it's what comes up. So we're going to drag that into here. I'm going to move the battery just down a little bit. I'm going to go ahead and just move this up so we can connect it. The way these push buttons work is this is like a mechanical button. This is like an actual thing that you can click and press in real life. I have an example of the button somewhere over here. Actually have this like exact replica. If you look at my screen, there are these little itty bitty buttons and you can actually click them like that. And this is what you can use when prototyping components and circuits in real life. So the, you know, without going into too much detail, basically the way you connect them is they're connected diagonally if you want them to act as a switch. So if you want, you know, the button to activate when you connect something to terminal 1, the other end should be connected to terminal 2B. So 1A connects to 2B and then 1B connects to 2A. Don't know why that is, but I'm sure Julian can talk about it later. So in our case, I'm going to connect the positive to 2A, change that to red, and then connect the diagonal 1B to the red line. So now if we hit start simulation, nothing happens. But if I click my mouse right on the black line and hold it, you have the red light turning on and off. If you want to, you know, have it held without you having to click it, you can hold shift and then click and then take your hands off and that holds the light down. And then you can click again to unclick it. Great. So now we have a way to like interact with our electronics. And this is already becoming a much more interactive type of circuit. You can add in 2 more push buttons and do the same thing. So now we can connect the green to the positive, the other end to the green of the LED. And then similarly, the blue to one corner, change that to blue. And then connect the other corner down here to blue. And now we've got 3 LEDs, 3 basically components of the LED connect each to a button to a battery. We'll hit start, nothing's happening. Press green, green lights up. Press blue, blue lights up. Press red, red lights up. Hold shift for red and let's hit blue. And now we've made magenta light. Awesome. Let's hit green. Now we've made yellow light if we mix red and green. If we hold shift on the blue and then click the green, now we can see that we've made teal light by clicking on and off. And then if you hold shift the green and then click the red, now we've made yellow light. So already this is now become an interactive circuit that you can use and actually use real components to play around with the different colors in real life. Thumbs up for people who've gotten there. Do you have any questions? Is this too slow, too easy? All right, we'll just keep going. But now you might be saying, great, you know, this is still not like the best thing. What if I want like my whole room to be covered in these LED lights, or I want this whole project, or I don't really want to have to press a button every time I want to change these lights. It's kind of annoying. I totally hear you. Let's get rid of this battery. Let's get rid of these buttons. And we'll introduce now a way to have these lights sort of do different things that we want them to do without us having to do too much work, at least physically. So let's go to, in all the components, you can search Arduino. And you should see the option for under microcontrollers, Arduino Uno R3. We'll go ahead and drag that in. And you should see that it's, you know, all even connected to a little USB cable. That's great. Drag it down here. That's awesome. The basics of the Arduino is that it has a bunch of pins that you can connect to. They're called pins. Give me 1 second to. Sorry about that. There's no designer on shift in person. Julian, I wish you could be here in person to help me out. So basically, Yeah, I know. We basically have a bunch of pins that you can connect to, and you can see that they're labeled different things on the Arduino. And this is actually what it looks like in real life. You've got a bunch of ground pins, A1 through 5, digital pins 0, 1, 2, 3, 4, all the way up to 13. They even have these little squiggly lines. Basically, those all signify that these pins can do different things when you connect to them. In our case, we want to be able to control this LED, right? To light it up just like we did before, but basically also control what kind of light comes out and how often it comes out or in what pattern. So we're going to move this to connect. Same thing. We've got the cathode connected to the resistor, and we're going to connect this ground, which is sort of like the negative of your battery, also to that resistor on the other end there. Right? And then we're going to work with just the red for now to get you started. And we're going to connect pin 9 to the red of the LED. Sweet. From here, instead of hitting start simulation, what we'll do is we're going to hit code, and you should see these cute little Scratch blocks come up. Scratch is a sort of visual programming language that was created, I think, by MIT to help teach kids how to code. Scratch is great. I highly recommend you check out Scratch if you're interested in learning code for the first time. For the sake of the workshop, we're going to actually work with text. So we're going to close out the blocks. And we're going to work with boring but very powerful straight up code. And this is what you would use to code the Arduino. Normally, you would be doing this in the Arduino IDE, which is what you would download from the Arduino website. Again, it's completely free software. They do a great job of explaining how to download it. But essentially, the code that we're going to be writing and uploading to this thing is this exact same. And so we've got essentially two different what we call functions running right now. We've got a setup function and a loop function. What this does is setup runs at when you turn your Arduino on or when you start your simulation, setup is going to do whatever's in the setup function. And then after that, the loop is going to run over and over and over infinitely until you stop the simulation or unplug your Arduino. And the loop is just going to execute all of these lines of code in sequence over and over. So what is this code doing? It's basically saying, all right, in the setup, we're going to establish that the mode of whatever's connected to pin 13, which is this pin over here, is going to be an output. So this is saying the mode of pin 13 is now an output pin. In our case, nothing is connected to 13, so we're actually going to change this to 9 because we actually connected our LED to pin 9. Everything ends with a semicolon except for things that don't. That's not super clear, but basically, if you have a line that's just like a command rather than like a function call or a loop, you want it to end in a semicolon. Then going into the loop, this is just like programming jargon. There's lots of documentation on how to look this up, but I'll try to explain this in as best a way possible. Now it's saying, hey, we're going to write or like send a command to whatever's on this pin, and it says 13, but we're again replace any 13 with pin 9. We're going to write to pin 9 digitally. So this is a digital pin, and you can see that on the Arduino right here. It says digital 9. Digital write to pin 9, a high signal, which basically means give it some voltage, right? Or more voltage than, non-zero. Then we're going to delay 1000. What delay 1000 means is we're going to delay a certain number of milliseconds. Any number you give it, it's going to say that's how many milliseconds I'll delay. So if you typed in 1, it would be like basically no delay. It's 1 millisecond, a very short period of time. If you type in 1000, that's 1 second. So delay for 1 second. And then to that same pin, we're going to send a low signal. And that's essentially going to turn off the voltage. And then we're going to delay 1000. And then delay again, and then just do this over and over and over and over again. Cool. So we'll close out the code. We'll hit start simulation, and you should see that the LED now turns red on, and then it turns off, and then on, and then off, over and over, infinitely until your Arduino is unplugged or runs out of battery, or the world ends, whichever comes first. We'll stop the simulation. That's really great. We'll open up the code again. That's awesome. A couple of things we can do, and this is like sort of going into the world of computer programming. We can actually create a variable to connect to our, sorry, there's things happening in the CEID. Give me 1 second. Basically in programming, a variable is something that you can create that holds the state of something. So in our case, we'll say that maybe a variable named red is going to be associated with the number 9. and that's just true always. In programming generally, at least for things are like C or Java, which is what C++ is what Arduino sort of talks in. You always need to declare what kind of variable it is. In our case, 9 is just an integer, and the shorthand for that is int. So you say int red is 9, right? And that's how we know that pin 9 is now sort of connected to red. And if we ever moved the red pin around, we can always just change this number, and that way we don't have to say 999 every time. We can just replace any 9s with reds. You should see that this works, even if we start simulation. Uh-oh, it's saying, what's happening? Did I mess something up? Oh, I accidentally hit the debugger. Stop simulation, start simulation. There we go, now it's working. It's going red. All right, cool. So similarly, we can say, how about int blue is equal to 10? We'll connect blue to 10, and then int green will be equal to 11. And we'll go ahead and do that as well in the actual circuit. So we'll say pin 10 is going to go to blue, change it to blue, and then pin 11 is going to go to the green. We'll change that to green. And we go back to the code. We haven't talked to these yet, so we're going to have to do the same thing again. So we'll say, hey, the pin mode for the, copy these lines again, blue is output, and then the pin mode for the green is also output. Just making sense? Thumbs up for people? Cool. And now we can say, okay, maybe what we want to do just to test this out is first turn on the red, then turn on the blue, and then turn on the green. And then we'll do that over and over. So I'm going to go ahead and just copy these 4 lines of code where it says digital write red high, then delay, and then low and delay. Copy that, open up some lines of code, paste it again. And then in this case, I'll just replace blue or red with blue in both those cases. And then we'll replace here red with green. You can sort of start to see the workflow. And then we'll close the code and hit start simulation. And now you should see that it turns on red, turns off, turns on blue, turns off, and then it should turn on green. Yay, we've made a programmable LED circuit that can now turn on different colors however we so choose. Now what this means is you can start to mix and match these colors in any way you want. So we don't just have to turn them on in sequence. We can say, okay, turn on the red, then turn it off, then let's turn on magenta. So in this case, I'm gonna delete these lines. We'll turn on the blue, but we'll also turn on the red. So I'll try digital write blue high, and then digital write red high, delay, and then turn the magenta off. We're gonna want to say digital write to the blue low, and also digital write to the red low. Start simulation. And you should see that it turns red, turns off, it turns magenta, turns off, and then it goes back to red. Maybe you might say, well, what happened if you turn the red and the blue high, and then you only turn one of them off? Well, it would basically just turn off the red component of the magenta color, and then we just go back to blue. So we're going to go red, then we're going to go to magenta, and then we're going to turn off the blue. Actually, we'll turn off the red so it just becomes blue, and then we'll wait a second, and then we'll also turn off the blue afterwards. So you can sort of see that. This is, again, just very basic circuit. Red, awesome. Magenta, awesome, and then blue. And go straight to blue. Cool. All right, any questions so far? Now, a reason I chose to specifically say, let's write to number 9, number 10, and number 11 is because they have these little squiggly things. And these squiggly things, you can sort of see it says digital, and then in parentheses, PWM squiggly. Remember back to my slides, PWM is basically a way of generating a pseudo analog signal. The reason that these colors, we only have right now these sort of like 6 or 7 different colors, is because we're sending full blast voltage to the red or the blue and then mixing those colors. And that's really all we can do when we just say turn it on or turn it off. If you wanted the entire color spectrum, so you don't want just like that specific shade of teal, but maybe you want it a little more blue or a little less green or whatever it is you want, you would have to send different levels of voltages, or rather different heights of signals to each of these components to then mix that around. And for that, you would actually have to use a different function. You would actually want to use an analog write signal. So I'm gonna go ahead and just delete, or actually, comment these out. Or actually, I'll just delete them. But first, I will share them with everyone. Oh, I didn't see Jack's information there on the chat. I just saw it now, but I should put this code in the chat in case you haven't been able to follow along. We're gonna go ahead and delete this and show you really quickly just what. So basically, we're gonna say, hey, Arduino, analog write instead of digital write to the red. We're gonna write 255. The reason we write 255 is because it works on a 4, is that right? 4-bit system, or 4-byte system. I don't know. Basically, the maximum values you can go up to are 0 and to 255. 255 means that you're sending the full amplitude to the signal, and if you were to then delay, a second, and then you were to send analog write 0, that would turn it off. And then if you were to send maybe a 100, that would be sort of like halfway between, and that would be a less dim light. And then it would loop back around and become brighter. So what this circuit will do now is turn on fully bright, turn it off, turn it on again a little dimmer, and then go brighter immediately once we loop back around. So let's see what that looks like. How do I move this? Hello? There we go. Okay, start simulation. So red light turns off, dim red light, and then bright red light. Actually, that's not super. Let's make it like 50 so you can really see how dim it is. Bright red light, dim, bright red light. Yay. And this is how you would start to mix and match the colors around. So say you wanted to analog write red 255, and then analog writes the blue 100. That would sort of create a different shade of magenta. So let's see what it looks like. Yeah, it's sort of like a more reddish magenta rather than a pure magenta. And what you can start to do is just play around with these different values and start to mix and match. Now you might see this and say, okay, that's great. Now we can programmatically send code to this LED so that we can change the colors, but that's still just one LED, and this seems like it's going to be very, very cumbersome to have to write like a bunch of code if I want to do like 1,000 LEDs. Luckily, there is again a solution for this. So we're going to go ahead, and now that we've gotten this far, we'll delete that. We'll delete this resistor, and if you in the search menu scroll all the way down to where it says LEDs, you should see under the LED options these things called neopixels. Essentially, what a neopixel is a smart LED that's connected to a pre-made mini computer internally that was created by Adafruit, which is an electronics supplier. This is Adafruit's store. You can always buy any electronic, basically almost any sort of Arduinos or Arduino modified things or components off of Adafruit. And something they specifically use is they created their sort of proprietary NeoPixel brand. And NeoPixels are essentially these like magic little lights that you can like very easily and like very quickly write different colors to, all with a couple of lines of code. And you'll see just how easy that is. So I'm going to rotate this so you can sort of see what we're dealing with. But you can see that there's a bunch of different pins on the NeoPixel. You've got a power, a ground, and then an in pin, and then a power, a ground, and then an out pin. The in and the out, the in is saying where's the signal coming from, and the out is saying if you want to put multiple of them together, you can connect them here. And this is just for the sake of demonstration, but I'll show you here. We're going to connect the ground to the ground. Wonderful. Black. We're going to choose pin number 6 now, just to switch things up, and we're going to connect that over to the in. And you might say, hey, I need 5 volts. I need power. What sort of power does it want? The Arduino itself can actually also, instead of giving like a pin that you can write to, it can just straight up provide voltage to something. Now, normally, let's see, how should we do this? These NeoPixels require more current than your Arduino can supply. Arduino has a maximum amount of current available. In this case, if we connected 5 volts over here and hooked it up to the NeoPixel, we would probably be fine. But for good practice, because I don't want you blowing up any NeoPixels if you get them later on, we're going to scroll down to where we have power options, and we're going to choose 1.5 volt battery. This is just like a 1.5 volt, and then over here in the like menu where it says count, you can choose 3 batteries, and 3 times 1.5 is 4.5, which is pretty close to 5 volts. So this is sort of our external power source that's going to provide as much current as we possibly want, somewhat, to this NeoPixel. So I'm going to rotate that. Again, this will all be recorded if you want to access it later. We're going to connect the negative, which is our ground, to the ground as well. The reason for this is because grounds always need to be connected if you're using various components that have different grounds. And then now the positive, which is our power, is going to go straight into the power of the NeoPixel. So we got red, black to both, and then green going to pin 6 of the Arduino. Does that make sense? Awesome. Now in the code, we might saying, okay, do we have to do all of this crap again? The answer is no. So we're actually going to delete, this. We're going to delete, pin mode, whatever. We're going to delete all this code because the NeoPixel has a library, and the library is essentially a chunk or a large chunk of pre-written code that somebody else has made public that you can interface with the Arduino and essentially say, include this library, and all of these code, all of these functions that have been created, you can just use them yourself. In this case, the library here is called Arduino Adafruit NeoPixel.h. All you need to do is copy this line of code. Oh, let me put this in the chat so you can see this. This is the link that I'm sort of using to copy lines of code in, but I am going to copy the code that I actually write so you guys can see it. Oh, so copy this line of code that says Adafruit NeoPixel. And if you want, you don't have to write this because I'm going to share all this code in a second. So hashtag include enclosed Adafruit _NeoPixel.h. This is the name of the NeoPixel library. And then in this tutorial, it's saying, hey, okay, if you want to use the NeoPixel, you need to do several things first. You need to specify where is the NeoPixel connected to. In our case, it's connected to pin 6, which is what I've already done. And we actually do this outside of the setup. So right before the setup even starts, we're going to declare all of these things. We're going to hash. This is just a line that says, this is just another way of declaring a variable. It says define that this thing called LED pin is connected to number 6. This is just a way of defining something. This is something that's never going to change unless you hand change it yourself. So this is like, you can type things in all caps. And this you don't need an equal sign or anything. You can just type 2037, and that's going to connect to pin 37. Then you're going to need to say, hey, how many NeoPixels are connected? And you'll see why this matters in a second. And here it's saying LED count 60. We don't have 60 NeoPixel LEDs. We just have 1. So I'll just say 1 for now. And then it's saying you need to declare that your NeoPixel object is existing. So we'll just copy this line of code again and put that right underneath there. And all this is saying, hey, using the Adafruit NeoPixel library, make something called strip. And this is sort of our strip right now, even though it only has 1. And it's going to include the LED count, which is 1, the LED pin, which is 6, and then this sort of variable that it requires is basically saying how fast are the lights going to be changing. I'm going to, again, just copy all this code for now. If you're directly following along, put it in the chat so you don't have to type it all yourself. You can put that in, and then we're going to keep going. So now you're saying, okay, how do we make this turn on and off? So instead of saying, hey, turn the pin, change the pin mode to on or output or off, all we need to do is say, hey, the strip, has to be lowercase, strip, which is what we called this thing here, strip. Dot, because it's an object, we can actually call functions to it. This is just, something. This is something. This is like an aspect of programming that you can enable. Strip dot begin, and this is saying, hey, in the setup, go ahead and start this strip. Strip dot begin semicolon. That's it. And then we can say strip dot show, and what this essentially will do is let us display whatever it is we're displaying on the NeoPixel. In this case, we're not displaying anything, so it's going to be empty. Then when we come down here, we can actually start to call different types of colors. In our case, we can say, okay, let's set the strip color, so strip.set pixel color, it actually has to be exactly like this. So it has lowercase set, uppercase p pixel, uppercase c color. And then it's going to say, all right, set the pixel number 0. In programming, there's a lot of programming jargon if you've never coded before. In programming, most things that are like the in line, 0 is what you start with. And then so, you know, your second object will be number 1, your third object number 2, and so on. So our 0th object is what we're addressing right now because we only have 1. Set number 0 to a specific RGB color. In this case, say we want to do just, you know, purely red, then we would send 255.00 to the strip. So just to review, this is saying, hey, that strip variable that we declared before, we're going to set the pixel color of pin 0 to 255 red, 0 green, and 0 blue. This does not inherently just change the color. What we need to do is actually, again, do strip.show, semicolon, and then we'll leave it at that. So I'm going to copy this code again. Actually, let's make sure that it works. So we'll hit start simulation, and you should see that the NeoPixel after a second turns red. You're like, great. We just had to do all this new work to do, you know, just turn something red. I'll show you why this is way more powerful in 1 second. Let me copy this code for you again so you have it. Bam. Awesome. Then you say, okay, what about other colors? Well, we can, let's delay 1000. So we can delay a second. And now let's set the pixel, let's copy these 2 lines of code over here. And let's say we want to set the strip pixel color to some sort of like turquoise. So we'll say 0 for red, 255 for blue, and 255 for green. And again, now you can see that we don't need to do any analogs or digitals. We can specify exactly like what varieties of the colors we want to set. So now we're going to set this to, you know, turquoise, and then again we'll delay 1000 before switching back to red. Go ahead and start simulation. So we should, once it turns on, we'll see red, and then turquoise, and red, and then turquoise, and now you have this cool little blinking light. And even though we had to like import this library and know that we're dealing with the NeoPixel and declare what it is, hopefully you can start to see that this is already like much easier to work with than having to write like analog write on, analog write off, you know, specify your colors. And this is like the most basic use of the NeoPixel library. You can even, if you wanted to in the library, it actually shows you how to do things like declare a color. So you could say, maybe you only want to reference something like called like magenta. Then you can say, let's see, where is it? Yeah, you can say like magenta is always going to be, this variable called magenta is always going to be equal to color 255.0.255. We're not going to do that just because we're running out of time. But in our case, you might be saying, cool, Antonio, like this is again still only 1 LED. Now we're going to delete this. And oh, actually, before we delete that, Control Z, so we don't actually, we'll delete it. That's not the new wires. And I'm going to search again NeoPixel. And now you can see that there's all these different options for different NeoPixels. So here we have a NeoPixel ring 12. And this is now a like string of multiple NeoPixel lights together. This is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if you hover over them, you can see it's power, ground, and in. And then of course there's an out, but we're not using the out, we're just using in. This is the exact same as the other one. So if we just connect them again, so go to pin 6, connect that to in, go to the ground, connect the ground to the battery, and also to the ground of the Arduino. And then we'll connect the power to the red of the battery. Without changing any code, let's see what happens. Now it's turning one of the lights red and blue. And you might be wondering why that specific light. Well, because we said, hey, turn number 0 on, and that is number 0. If we were to say, hey, this LED now has 12 lights, let's just add a 2 there. So we have LED count 12. Now we say, hey, I actually want to reference pin number 6. Pin number 6 for both. Start simulation. Now we'll see a different light bulb start to light up. It's this one over here. Red, blue, red, blue. Lots and lots of fun. And here's where you can start to have be really creative with the different lights that you start to put out. So let's move this down a little bit. And a programming thing, I don't know who's coded here before, but there are these things called loops. So you can create a loop that is going to do something over and over until it fulfills a certain condition. In this case, the way you declare a loop is in Arduino code, you just write the word for. You can write for, open the parentheses, close the parentheses, open the bracket to write your code, and then close the bracket down here. And then within the for, we're going to declare a new variable called integer, int, int, let's call it just like I, just for the sake of simplicity, I. Write a semicolon. This is like a whole CS lesson. If you've never coded before, just bear with me and just like follow along, or just copy the code and trust that it works. We're going to say only run this loop until I only run this loop if I is less than a certain number. And the number that we're going to say is actually the LED count. So no matter what number we put up here, this LED count is always going to be the maximum we can go to. Hit a semicolon. And then how are we moving I up and down? We're just going to say I++, which is essentially saying, hey, next time you go through this loop, increase the value of I. And actually, what is the value of I? We have to declare that as 0. So this loop should now say for parentheses int I equals 0 semicolon, as long as I is less than this number called LED count, and then always increment I every time to the loop. That's your very basic cookie cutter for loop. Now we can start to specify what we want to do. So first this loop is going to turn this one light red, that's going to turn it blue. And then maybe we want to say, okay, let's set the pixel color of, instead of 6, we're going to say I, right? Because this is like, it's a variable now. We're saying every single one. Set it to, let's do, green, right? So let's do 0, 0, 255. And then delay just, half a second. So instead of 1,000 milliseconds, we'll say 500 milliseconds. And that's it. So then, and then of course we have to actually show that we're changing that. So strip.show. So review this. This is going to say, hey, for every single light, change that light to green, wait a second, show it, and then do that for the next light. So let's see what happens with this line of code. Start, it'll turn red. It'll turn blue because we never deleted those lines. And then it'll start to move blue light. Oh, I accidentally hit blue instead of green. Blue, 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 blue for every single component that we want. And then it turned that red and blue, and then it's going to turn all those blue. You might be wondering, okay, why isn't it turning off? It's because we didn't tell it to turn off. So maybe at the very end we want to say, hey, strip.clear. And this is just another built-in function that exists within NeoPixel library. And of course, after anything, you want to do strip.show and all. So you can see that. Start simulation. Hopefully it'll be a little faster now. We've got red, we've got blue, and then we've got all the different lights. And then hopefully it should erase itself and then turn red again. Yay, it did that. You sort of see that it glitched out, but it's just because this simulation is not perfect. And then like basically there you have it. What's beautiful about this is like we didn't write that many more lines of code, and we actually just wrote a loop, but we were able to add 12 more little LED lights without having to do too much. So you can imagine that now if you go ahead and deleted this, and you wanted to add a light strip that had 20 LEDs, and you can like zoom out to see just how big that is. This is going to work like literally in just the same way. So once again, ground to ground, ground to ground, black, power to 5-volt power. Sorry that I'm being a little messy now. And then in, it's going to go to 6 because that's what we said. This one has 20. So in our code, we're going to have to change this to 20 instead of 12. And now we can say, okay, every time we start the loop, clear the strip, and then delay, 20 milliseconds. And then let's get rid of these lines of code. we can start to play around with the colors. So maybe we want, first we want it all to be blue, and then we want, let's delay just another bit there. And then we want to copy this whole loop again and maybe change this now to magenta. So we'll do 255 on the red, or maybe a softer magenta. So we'll do 255, 0, and I don't know, 200. And we'll go a little faster. So we'll lower the delay time. And then you can start to basically play around with however you want to do this. And zoom out, we'll see how this looks like. So stop simulation. Now it's going to do all the blues. Hopefully a little faster. It's a little slow because of zoom and everything. And then it's going to turn it off. And then it's going to go through all of them and do magenta. And it's going to turn off, and it's going to do it all over again. And similarly, just like we had it a button before, if you wanted to, you can add a button here and say, every time I push this button, send different colored lights over here. Maybe you want to go through and you see that, you can add a distance sensor, right? So maybe you wanted to put these up in your room or on a robot, and you added in this distance sensor and said, hey, anytime something gets within 5 feet of this distance sensor, start flashing these lights red and blue, like a cop car. Or maybe you have a motor in here and you say, hey, when this robot, comes within 5 inches of this, material, start spinning its arms back and forth and light up the lights. There's tons and tons and tons of things that you can do with electronics. And what's nice about this Tinkercad thing, even though it's definitely like limited and it's not the same as like actually lighting things up in real life, it lets you prototype them. And the good thing is, they're definitely, like, while they're pretty cheap, they're not like super cheap, these things. And like, you know what you're doing, you wouldn't want to risk like blowing these things up and having to buy more. With Tinkercad, you don't have to worry about blowing it up. You can blow it up all you want. And that way you can prototype different things before actually having to go in and buy some, or coming to the CEID and using our own materials without really knowing what you're doing. So that is officially like the end of the electronics workshop. And I know that was a lot of information with both electronics and code, but hopefully that helps you give a little bit of an introduction to what you can do with electronics and really empower you to start building your own. Somebody brought up today that, a cool usage of this LED strip is you can make a lightsaber. So you could put this with like, a strip of acrylic and, press a button and then the light lights up in sequence. And that's a pretty cool thing. You could be super basic and put them on your, desk, and like that way be like a gamer person. All sorts of stuff you can do. Now you might be wondering, okay, like I have no idea how to interface with this like, sensor or this motor. There's so much documentation online on how to do this stuff, especially with Arduino. So this is called like a servo motor. And if you're ever wondering, how do I use a servo? You can search up like Arduino servo, and it literally will tell you, oh, you want to use a servo? Then this is the kind of code you write. Let me just get back. It's saying, okay, this is the code that you would write. And you can also, it usually comes with a schematic. So the Arduino website is a great resource to look at. Another great resource is, here it goes, sweet, that's it. So the Arduino website shows like, okay, connect the servo to this pin, to the ground and the 5 volts. This is what it looks like as a schematic, and this is the code, you can copy it. The servo motors actually also have a library that you can use. So that's I'll just copy this like directly to the chat so you can sort of see directly what it's doing. Another great resource that I'll say before we turn off is the SparkFun is another website that's very similar to Adafruit. So with Adafruit, they have tutorials for basically everything that's on their website. So if you buy a NeoPixel from them, or you get your hands on a NeoPixel, they have that tutorial that I sent you, and a million other tutorials and other inspirational projects that you can do. But SparkFun, you can do the SparkFun. I think it's called SIK something. Inventors, yeah, SparkFun Inventors Kit tutorial. And here it is, 4.1. And this essentially is like a online version of this book that we have here in the CEID that I would highly recommend to anyone that's looking to get into understanding how to control various electronics. And like basically the end of the kit, you can actually build this little robot that I showed you at the beginning. that responds to light, and you can put your hand in it and it'll like drive away from you. Lots of really cool fun stuff. And it'll show you how to actually like light up an LED, do what we did, how to add like a knob to change the brightness, how to add a speaker. This is called digital trumpet, so make with that what you will. How to add a screen that types text, how to sense what temperature it is, how to make a little robot, all sorts of fun stuff. That's a really great usage. I'll put this in the link as well for you to learn how to get started. So with that, that's the end of the workshop. Thank you, everybody. Does anyone have any thoughts or questions? I know it's a small group, but love to hear from you to see what you thought.
I just had one quick question. I just wanted to make sure if you want to do like household voltage or like 120 volts, you just use the function generator and set the amplitude and the hertz and all that.
Yeah, if you're in the CEID, you can use a function generator to decide what voltage you want. I will say we do not allow wall voltage or amps to be plugged in and then used in our project here because danger. That's just like a general rule. But yes, it works the same way. I would be careful if you're working with 120 volts. But we do have a function generator here that can output like 5, 10, 30 volts, whatever.
Okay, yeah, just like on Tinkercad, I was looking at.
Oh, yeah. You can use a function generator to give out voltage. Any other questions or thoughts? And feel free to head out. We can be done. Great.
Yeah, thanks. I think, did you say like the one next